In this tutorial, we will take a look at various volumetric and subsurface scattering effects that we have in Corona Renderer. So, what are those effects? First of all, let's take some materials with various properties. We can divide those properties into two categories. The first category is things happening on the surface, such as diffuse color, reflections, or bump. And these properties let us define what the object surface looks like. Is it blue or red? Is it reflective or not? Is it rough or smooth? The second category is volumetric or subsurface properties, such as translucency, absorption, subsurface scattering. These let us define what happens under the surface, inside the object volume. Does it let light to the other side? How far can the light travel inside an object? Does it scatter light, and in which direction? Rather than explaining each parameter one by one, let's take a look at how to create various volumetric materials and how to control their appearance. So the first kind of material that we can use to get volumetric effects is the standard Corona material. It can be used to create effects which are happening both on the surface and in the volume. So to demonstrate those things, we will be using this very simple scene. It's basically a kind of studio made out of a cylinder with chamfered edges, and then we have three different lights inside, shining from different directions to see how they interact with the surface and with the inside of various objects. So let's start Corona Interactive to see what we have here. And the first kind of volumetric materials that we can create with the standard Corona material is the kind using translucency. And an example of object which can use such material is leaf. So I will unhide my leaf that I have in my scene. Leaf here, okay, unhide. And this leaf object is using a material from our Corona material library. As you know, leaves are very thin things which let some light pass through them, and for this we can use translucency. So let's check this leaf material. I'll just grab it from the scene, and here we have just a standard Corona material which is using translucency. While technically translucency only works on the object's surface, it is actually used to simulate very thin subsurface scattering objects just like leaves or paper. So if we disable some of the lights, like the top one here and the left one, we now only have this light working or enabled, and you can see that it's shining from this direction and it's reflected on the surface of this leaf. But if we look from behind, we will see that there is some light passing through the leaf and getting to the other side. So if I disable this light, you will see that the scene is completely black, there is no other light source. And if I enable it, you will see that it's shining on the leaf and then passing through the leaf. And another way to prove that translucency is actually working is that if I disable it completely, you will see that now there will be no light on the other side of the leaf. So if I start increasing it, it will become brighter and brighter, basically deciding about the thickness of this leaf and about how much light it passes to the other side. Okay, so again, with this single parameter, we can create basic subsurface scattering or translucency effects, and this is useful for thin semi-transparent things like leaves or paper. Now the other thing which is using volumetric effects and which in real life isn't ever fully transparent is glass. So if glass is thick enough, it will always show some color, and eventually it will consume all light entering it. Let's unhide some object which will allow us to create some nice looking glass material. So unhide by name, and we can use maybe this mug for our tests. And I will just hide all the other objects, so it's easier to see the effect of glass absorption. So let's hide the liquid and the ice cubes. Okay, like this. And what we have now is a very simple glass material. So if we sample it, you can see that it's just a standard corona material with diffuse level set to 0, reflection set to 1, and refraction set to 1. And then it's just fully transparent. It doesn't color the light which is entering the mug, and the glass is not getting darker in any place. It's just fully transparent and completely clear. So if I want to create colored glass or darker glass, I can go to Volumetrics and SSS without changing any other properties and just increase absorption distance. So let's try with 1 centimeter. And this means that after traveling 1 centimeter, our white light becomes darker. Increasing this absorption distance value will make our glass brighter. So I can just fine-tune it like this. And one way to find the best absorption distance value that you need is setting the absorption color to pure black. So let's do it. And then adjusting the distance. This basically means that now we know how far the light can travel before it becomes completely black. So it's just an easy way to tweak this absorption value. Of course, it's also possible to use colored absorption. So let's set it to some sort of blue or slightly greenish color, like this. And with this enabled, with the color enabled, we can again change the distance to make it darker or consuming the light faster, or brighter or consuming the light later. Okay, and now you may be wondering what is the difference between absorption color and refraction color. So as you can see, with absorption color, some parts of the object are almost fully transparent, so they are brighter, and some parts are colored, and this is especially visible if we lower the absorption distance. So maybe with 3 centimeters, you will see that some of the places are more transparent, while the thicker places are more colored or slightly darker. And this is what absorption works like. And if we use refraction instead, so I will just disable absorption to get completely transparent glass again, and I will use the same color for refraction, you will see that now the object is evenly colored. So using refraction is like covering the glass with some transparent colored paint, while using absorption color is more like changing the color of the volume or of the inside of the glass. So this is how you can easily set up glass in your scene and make it colored or make it darker. This is of course useful for things like window glass or tabletops. And now let's take a look at some other volumetric effects that you can create, and we will try setting up some sort of wax or marble. So first let's unhide an object that we can use to show you how to set up wax. So I will hide this mug here, and I will unhide our candle, and this is what it looks like. We already have some sort of subsurface scattering material, and maybe I will enable some other lights to just see it better, how lighting affects our material. Yeah, so it's already using some sort of subsurface scattering material, but let's try setting it up from scratch. So I will just create a new corona material. So again, we are just using the standard corona material, nothing special. Let's select our candle and apply this corona material to it. And now the easiest and fastest way to set up things like wax is enabling the SSS mode in a corona material. So once again, if we go to Volumetrics and SSS rollout, we have two modes here. One is Volumetric Scattering, and this is the one which we used to create colored glass, and the other one is SSS, which is the simpler and faster way from these two. So if we select it, we can see that the settings here become available now, so subsurface scattering amount and radius and scattering color. And we can also see that translucency and refraction become grayed out and they are just not available. And this is because these things are not supported together. If you enable subsurface scattering, you shouldn't touch refraction or translucency. It's just not possible. So once we enable this SSS mode, we can just increase the subsurface scattering amount to see the SSS effect. Okay, of course, if we increase this amount, we can see more of subsurface scattering. It becomes more apparent, more visible. And if we increase the radius, we basically define how far the light can travel inside this object. So let's try increasing it to 2 centimeters, or let's try with some higher value like 10. And this means that this object basically becomes more translucent or more transparent. It lets more light pass through it and scatter inside it. So we know the basic controls, so now let's try setting up some simple wax material. So maybe first let's disable the subsurface scattering, just set it to 0 and define what color of candle we want to have. So let's try with something close to yellow, maybe like this. And of course we can also use reflection, reflectivity and other parameters that we have here. So let's enable it. Let's set glossiness to some realistic value like 0.6, and we can even enable some anisotropy to get those nice vertical reflections on our candle. And once we are happy with the surface, we can start enabling and tuning the subsurface scattering parameters. So let's increase the amount. Let's try with something like 0.5, and I think we are pretty close to some realistic results. So we can probably keep the amount like this, and maybe we can just slightly reduce the radius to make it a bit more solid, a bit more thick. And once we are happy with the amount and radius, we can just change the scattering color. So maybe let's also try with something closer to yellow. And you can see that it's giving us this really nice subsurface scattering effect. It's quite subtle here, so maybe we can increase it a little bit. And we can also disable some of the lights to just see it better, like this. So like I mentioned, this simple SSS mode allows you to quickly set up materials which scatter light inside. But for more advanced materials and for better control, you can use the volumetric scattering mode. And let's just quickly take a look at what happens when you switch to this volumetric scattering mode and what controls become available. So I will just unhide some object. Maybe we can try with the hand here. It's already using some sort of material, but we can create a new one. So create corona material. So again, we are using just the standard corona material. And once we go to volumetrics and scattering, we can make sure that volumetric scattering mode is enabled. And once this is done, nothing happens. Even if you change the distance, you will see that the hand just remains completely the same and nothing is happening. And this is because currently we only see the surface of this object and we do not actually see the volume. So to make these subsurface scattering, these volumetric effects visible, we have to somehow make the surface transparent. And for this, we can use three properties available in the corona material, and those include opacity. So by lowering opacity, I will let some light pass through the object and see the volume. Then there is translucency. So like with the leaf example, we will make the material translucent and light will pass through the surface and go to the other side. Or we can use refraction, and this is like in the case of glass, where light is entering the inside of the object, then is refracted and it passes to the other side. So what kind of materials can we get using those settings? Let's explore them one by one. So first, that would be opacity. So I can set opacity even to 0 just to completely remove the surface, and then I will see the inside or the volume of my object. So once opacity is set to 0, I can increase absorption distance, and this will immediately show the volume, the inside of our hand. And setup like this with opacity set to 0 can be used to create materials like smoke or clouds, which do not have any kind of surface whatsoever and only have some sort of volume. So once we do it, we just like with the glass, with absorption distance we define how dense the material is. So if I decrease the distance, it will get darker and denser, and if I increase it, it will get brighter and more thin. And with scattering color, I decide about the tiny little particles that are inside this object and which scatter the light inside. So if I make it brighter, it will scatter more light. Of course, I can also use some color here. Let's try with some pink, and this will be like the overall color of the volume of this object. So again, this is some sort of smoke or cloud or colored gas, and it doesn't have any surface at this point. Of course, if I increase the opacity, I will show some of the surface, and at the same time I will show some of the volume. So if we leave the volumetric settings like this and try with some other property than opacity, we will get a different result. So now let's say that we want to create some sort of plastic which will be pink on the outside, and also it will have some sort of pink or red color on the inside. So for this we can use translucency, and similar like with the candle, we can first decide what should be the color of the surface of this object. So let's try with some bright pink hue like this, and then we can enable some translucency, and once we do it, or even if we set it to 1, we will see the volume, the color which is specified here under scattering color. And this is because, once again, we are allowing some light to pass through the surface of this object, and then all the volumetric effects are happening inside. Okay, so once again, let's give it some pink color like this, and just like with the previous examples, we can now define what should be the absorption distance, absorption color, scattering, and all the other parameters that we have here. And again, like with the candle, we can enable reflectivity. We can lower the glossiness just to try to make this material more realistic. Okay, and the last property that we can use to create volumetric effects using the volumetric scattering mode is refraction. So let's apply a new material to this hand, and I will basically make it glass. So let's set diffuse level to 0, reflection to 1, and refraction to 1. And then let's make sure that volumetric scattering is enabled, and we already know the parameters, so let's just set distance to 1 centimeter and enable, and this time let's enable some scattering color. So this is similar like before. We have some surface which is reflective, and we have the volume. And other than that, we also have refraction enabled, so this object refracts light. And if we look at it at some specific angle, we should see the light behind it. Let's just make sure that it's visible. And maybe let's disable the other lights. And here, for example, on the finger, we can see that it's reflective, and it has some volumetric effects, but it also refracts the light which is behind it. Okay, so depending on what you need, you can use the volumetric scattering mode with opacity to create things like smoke or clouds which do not have any kind of surface, with translucency to create things which do have some surface and let light pass through them, like plastic or rubber, or you can use refraction to create glass with some sort of volume inside it. Let's stop here and see you in the second part, where we will talk about the Corona skin material.